1, 0. And I believe we are live at Colorado State University's engineering department at an undisclosed location. And here we're going to have a look at lab number 10, parts 1 and parts 2. We're going to start off with part 2 just for convenience here. And what we're doing today is looking at a sequential circuit that is a hardwired circuit for implementing a series of integers, an arbitrary series of integers. Ours today happens to be a certain sequence of integers, and we're going to go through that and demonstrate that our hardwired circuit can indeed generate these sequences. So let's give it a try. We're all set to go with part 2. Now this is going to be what they call a toggle flip-flop, a T-type flip-flop circuit used in the, or device used in the circuit. Again, it's a toggle flip-flop. And we're going to go, I'm going to count as we go through the sequence so that you can see that the numbers coming up on the display are indeed the sequence that we are interested in. So here we go. And we're going to press the clock button. And we're going to count through the sequence. First one, of course, is going to be 0. We're at a blank right now, so we're going to go 0. And yeah, we can see that 0. Now we're going to go to a 9. There's your 9. We're going to go to 11. There's an 11. Then we're going to go to a 12. There's a 12. Then we're going to go to a 13. And there's 13. Then we're going to go to a 7. There's a 7. Then we're going to go to a 6. There's a 6. Then we're going to go to a 5. There's a 5. Then we're going to go to a 14. There's our 14. And then the last number in the sequence is going to be a 2. So when we hit the clock, we get a 2. Now what's going to happen is if we hit the clock again, we're going to go back to 0 and repeat the whole process. So clock 0. I'll just go through these real quick. 9, 11, 12, 13, 7, 6, 5, 14, and 2. And of course back to 0 again. So there you have it. That's part 2 for the toggle flip-flops being used in a circuit to generate a sequential numbers. So what we're going to do now is go back over to part 1 where we're going to be using a D-type flip-flop, and the D is usually meant for delay, a delay flip-flop. So this is going to take a minute or two to change the circuit and download the D-type flip-flop circuit. And it's going to be the same exact sequence that we just looked at, but it's going to be using a different circuit. And we're coming up on the file here. And we're looking looking for the D flip-flop circuit, and that'll be coming up here in a minute or two. Unfortunately, it takes a little bit of time to load these programs into the FPGA here. And again, we're just going to go through the sequence of numbers, and it is an arbitrary number, or arbitrary sequence of numbers. It could be any number you choose, but for the lab, we're just going to use the sequence, one of the sequences that we were given. And the program's still loading, or I should say the file's still loading. And I'll try to get a bit of a pan here around the room. Okay. All right, I don't know how good that is, but anyway. We'll put that back down. Looks like our file should be loading up here shortly. And it is taking quite a long time for this file to load up. Hopefully it won't take. We were having some trouble with one of the segments of the LEDs, so we had to get in there and fix that. So there was some issues with getting this to work as good as possible. So here we go. Our file has loaded. That's a good sign. And we'll go ahead and program the FPGA. You try to get this so you can notice the program getting loaded. Okay, here we have a 00 from our last test. Start the download. Okay, we're all ready to go. We're going to again go through the sequence. And I will announce them, and then I'll push the clock button. Okay, we're sitting at pre-0. Okay, now we're at 0, 9, 11, 12, 13, 7, 6, 5, 14, and 2. And back to 0, of course. We'll go through it one more time just to make sure. 9, 11, 12, 13, 7, 6, 5, 14, 2, back to 0, and there we have it, folks. We can chalk this one up. Chalk up Lab 10 parts 1 and 2, the sequential counter, and that's going to be it for us today. So we'll see you next time. We are out.